Alright, so let's just take a look at some of the postulates that are listed out in section 1.2. These are all in your textbook as well. I just typed them up for you, and I just have them in another spot. Talk about them just a little bit. So, given any two distinct points in space, okay, then there's exactly one line that passes through them. If I have 2 points, doesn't matter where they are. There's only one line I can draw through points A and point B. Only one distinct line. Any 3 distinct points in one plane. Okay, so if you think about it, if you have if we were in person, I would kind of hold up 3 non-collinear points. Okay, non-collinear for exactly one plane on those 2. The line determined by any 2 distinct points in a plane is also contained in that plane. So if you have a plane, if both of these points are on the plane, then the entire line that contains those 2 points is also on the plane. There is no plane that contains all points in space. Space is 3-dimensional, a plane is 2-dimensional. Now I have this ruler postulate that says there's a one-to-one correspondence between the set of all points on a line and the set of all real numbers. If you look at page 13 in your textbook, there's a little more explanation on that with some diagrams you can look at. So you can make a number line, and any points on any of the real numbers, you can order them. Okay, so the points associated with those can be put on a number line. They are distinct if they are distinct real numbers. Okay, take a look at some of those examples on that page there. Now these next properties are properties of equality. So reflexive, I like to think about the word, maybe it reflects. When you look at your reflection in the mirror, you see yourself. Any number, any quantity, any number is equal to itself. Okay, and the reflexive law is going to come into geometry as well, and things with other than numbers. Now, the symmetric law says if x equals y, then y equals x. Okay, so there's some symmetry there. Think about, something that has a line of symmetry. I was thinking about, like, when we wanted to cut out a heart, we'd fold it on that line, so we could cut it and open it up and it'd be the same on both sides. That would be symmetry. It's kind of like that here, where it's the same on both sides. It doesn't matter which side of the equal sign they're on. If they're equal, they're equal. The side doesn't matter. It's the same on both sides. Transitive, think about the word trans. It goes across. You translate something. It's a language. You transport something. You carry it across. If x is equal to y and y is equal to z, so notice this. This is kind of going to take you back to section 1 with that kind of like syllogism with the logic. Then x is equal to z. So that middle stuff matches because we're translating. Let's say x took us to y, y took us to z. If we start at x, eventually we're going to get to z. So transitive property. Middle stuff matches. That's important with transitive. Then they have all these laws in your textbook as well. The addition-subtraction law. So we know that w and x are the same. We know that y and z are the same. So we should be able to add, w plus y should equal x plus z. It's kind of like adding the same thing to both sides. When you were in an algebra class, you could do that. When you're solving equations, you could add the same thing to both sides. Well, they added y to this side and z to this side, but y and z have the same value, so that's okay. And that would also work with subtraction. If you subtract y from one side and z from the other side, as long as they have the same value, it should still be the same. It would work also with multiplying and dividing. Okay, so postulate 1.10 is the same, except with multiplying and dividing. The only thing you have to be careful of here is that you're not trying to divide by 0. So if we know that w and x are equal, we know that y and z are equal, we could multiply, and our results should be equal. We could divide, and our results should be equal. Just be careful about, as long as y or z are not 0, because then we'd be trying to divide by 0. The substitution law. Substitution comes into play when we have to do proofs later on. And there's a couple of different kinds of substitution. And it's just saying, you know what, if two things have the same value, they can be substituted for each other. Okay? In any expression. Okay? So you're going to look for that. Some substitution situations where, well, we're just going to replace, since x and y are the same, I'm going to replace that x with a y. I'm going to replace that y with an x. Distributive law is something you probably remember from algebra. If it's x times the quantity y plus z, that means it's x times y plus x times z. Okay, so those are properties. Again, there's also explanation for those in your textbook that you could take a look at as well.